Now the next set of three identities. So these identities are Z1 plus Z2 whole cube equal to Z1 cube plus 3 Z1 squared Z2 plus 3 Z1 Z2 squared plus Z2 cube. Z1 minus Z2 whole cube is equal to Z1 cube minus 3 Z1 squared Z2 plus 3 Z1 Z2 squared minus Z2 cube, and Z1 plus Z2 into Z1 minus Z2 equal to Z1 squared minus Z2 squared. So we can prove this one by one. So the first Z1 plus Z2 whole cube. So we have Z1 plus Z2 whole cube equal to, this can be written as this Z1 plus Z2 whole squared into Z1 plus Z2. And this Z1 plus Z2 whole square can be expanded using the first identity. So this is this Z1 squared plus 2Z1 Z2 plus Z2 squared into this Z1 plus Z2. Z1 plus Z2. And this is again equal to. So apply this distributive property over addition. So here we have three terms. So the distributive property is applicable for these three terms also. So multiply all the terms with the Z1 first and then multiply all the terms with the Z2. So we see that this is equal to Z1 squared into Z1, which is Z1 cube plus 2Z1 squared Z2 plus Z2 squared Z1 plus then with the Z2 Z1 squared. So Z1 squared Z2 plus 2Z1 Z2 squared, 2Z1 Z2 squared plus Z2 cube. This is again equal to the first term Z1 cube plus 2Z1 squared Z2, then Z1 squared Z2, which is 3Z1 squared Z2 plus Z2 squared Z1 and 2Z2 squared Z1. So we see that this is 3Z1 Z2 squared and then Z2 cube plus Z2 cube, and this is the required result. And then the second is this Z1 minus Z2 whole cube. So this can be written as this Z1 plus minus Z2 whole cube, which is equal to, this can be expanded exactly similar to this. In place of this Z2, take this minus Z2. So putting minus Z2 in this expression, we will get the required result. So substituting minus Z2 in this last step, we see that this is equal to Z1 cube, then plus 3Z1 squared into Z2. Place minus Z2 in place of this Z2, we get minus 3Z1 squared Z2, then plus 3Z1 Z2 squared. So placing minus Z2 in place of this Z2, we get this plus 3Z1 Z2 squared plus 3Z1 Z2 squared, then placing minus Z2 in place of this Z2 minus Z2 whole cube, which is minus Z2 cube. So minus Z2 whole cube is minus Z2 cube minus Z2 cube. So which is the required result. And then the last identity Z1 plus Z2 with Z1 minus Z2. So this is this Z1 plus Z2 into Z1 minus Z2 is equal to Z1 plus Z2 into Z1 plus minus Z2. minus Z2. And this is equal to, applying the distributive property. So we see that this is equal to is Z1 plus Z2 into Z1 plus Z1 plus Z2 into minus Z2, which is equal to this Z1 into Z1 squared plus Z2 into Z2 Z1 plus Z1 into minus Z2 minus Z1 Z2, then Z2 into minus Z2 minus Z2 squared, and Z1 Z2 is Z2 Z1. So we see that this is same and numerically opposite. So cancelling these two, we see that this is equal to Z1 squared minus Z2 squared. So this is the required result. So we have totally 5 identities. Okay.